Hello everyone, welcome to TCE online course on marketing and social media web analytics. In today's lecture, we will discuss an important topic titled Sentiment and Semantic Layering over Networks. So far we have learned how the network capture connections and structure. In this lecture, we move one step forward by adding the meaning, sentiment and emotions to the networks. This topic is extremely important for understanding public opinion, brand perception, crisis behavior, and campaign effectiveness. This lecture is a part of social media analytics, making connection part 2. At this stage of the course, we move from structural analysis to context aware analysis, where we ask not just who connects but also what they feel and discuss. In this lecture, we will cover why sentiment and semantics matter in networks, how NLP combines with network analysis, semantic and sentiment layering, topic and hashtag networks, emotion diffusion, and real-world marketing applications, and quiz. Why sentiment and semantics in network? Social networks carry both structure and meaning. Connections alone cannot explain opinion, emotions, attitudes. Sentiment analysis reveals public mood and perception, while semantic analysis explains what people are talking about. Together, they are essential for marketing analytics, crisis monitoring, and brand reputation analysis. Combining NLP with network analysis. Network analysis focuses on structure, influence, and connectivity. Natural language processing extracts meaning, topics, and sentiments. When they combined, they create context-aware networks where text became nodes attribute, interaction became meaningful edges. This enables multi-layer network analysis. Text as network attributes. In these social networks, posts and comments are linked to users. Replies and mentions are linked to edges. Hashtags acts as semantic signals. Keywords enrich nodes' meaning from the basis for semantic layers in networks. Semantic layering in networks. Semantic layering adds topic-based layers over the network structures. Each layer represents a theme, a concept, a discussion topic. Nodes can appear in multiple layers, allowing topic-specific influence analysis and tracking discussion evolution over time. Sentiment layering. Sentiment layering assigns sentiment score to text. Common sentiment labels are positive, negative, and neutral. Sentiment can be assigned to node level or edge level. This supports opinion monitoring and perception analysis. Topic networks. In topic networks, nodes represents topics or keywords. Edges represents co-occurrences. Topics are extracted using NLP techniques. These networks help identify dominant themes, discover emerging trends. Topic modeling and networks. Topic modeling extracts latent topics from text, Topics can be associated with users, associated with communities. Topics may become nodes or attributes. This allows us to compare communities and analyze topic evaluation. Hashtag co-occurrences networks. In hashtag networks, nodes represent hashtags. Edges connect hashtags used together. Edge weights show frequency. Clusters are often represent campaigns, movements, and events. These networks are widely used in social media analytics. Insights from hashtag networks. Hashtag networks help identify campaign spread, detect emerging narratives, monitor brand discussions, and understand audience alignment. They directly support making decisions. Sentiment polarity in networks. Sentiment polarity measures positive versus negative tone. It can be assigned at post level, user level, community level. Polarity often varies across different regions of network, revealing polarization. Polarity spread across communities. Sentiment spread through social ties and homophily. This leads to echo chambers, polarized communities. Influencers play a crucial role in amplifying sentiments. Network structure strongly shape opinion and diffusion. Emotion analysis in networks. Emotion analysis goes beyond sentiment. It detects emotions such as joy, anger, fear. Emotion strongly affects engagement intensity, especially during crises and public events. Emotion diffusion in online environment. Emotions propagate through interactions. Few key observations are: it is highly connected nodes spread emotions faster. Negative emotions often spread rapidly. Community structure affects emotion flow. This provides early warning signal during the crisis situation. Temporal dynamics of sentiment. Sentiment is not static. Events trigger emotional spikes, sudden polarity shifts. Temporal layer capture evolution, peak phases, recovery phases. This is very useful for campaign evaluation. Community level sentiment analysis. At the community level, we aggregate sentiment, compare emotional tone, identify polarized group. This enables targeted interventions, micro-segmentations strategies. Real-world applications. Applications include political campaign monitoring, brand reputation management, crisis and disaster response, misinformation analysis, customer feedback mining. So let's see one by one. First one is campaign analysis. In campaign analysis, hashtag networks show reach. Sentiment layer shows audience reaction and topic layer reveals focus areas. Emotional layers capture excitement or anger. This guides campaign optimization. Next one is crisis and brand chatter. During crisis, negative sentiment spikes quickly. Anger and fear dominate. Communities react differently. Influencer accelerate diffusions. So, early detection significantly reduce brand damage. Challenges in semantic and sentiment networks. Few key challenges in semantic and sentiment networks are sarcasm or irony detection. Sarcasm and irony detection, noisy social media text, multilingual content scalability, interoperability of sentiment model. To summarize, networks gain value for sentiment and semantic layers. NLP adds meaning to structure. Topics and hashtags, networks reveals narrative. Sentiment and emotion spreads through communities and essential for real world social media analytics. So now let us see few quiz questions on these topics. I will read each questions. You can pause the video and try to answer the video. First one is sentiment layering in network ads. Option A, random edges. Option B, meaning and topic context. And option C, more nodes. The answer is meaning and topic context. Second question. Hashtag co-occurrence networks are built based on user friendship, joint usage of hashtag, temporal order. The answer is joint usage of hashtags. Third one, sentiment polarity typically represents topic frequency, positive or negative opinion, network centrality. The option is positive or negative opinion. So fourth question, emotion diffusion refers to random emotion assignment, spread of emotion through network ties, and topic clustering. The answer is it's spread of emotions through network ties. Fifth one, why combine NLP with network analytics? Option A, to ignore structure. Option B, to gain context aware insights. Option C, to reduce data size. The answer is to gain context aware insights. So in this video, we have discussed about the sentiment and semantic layering over networks. In the next video, we will discuss further about the integrity and trust anomaly detection in networks. So if you have any doubts, kindly feel free to contact me at any time. Thank you. Happy learning.